Okay, so now I'm going to explain performance and optimization. So for performance of and optimization, what I'm going to do, I'm going to take the same old code that I used to fetch from the APIs, and I will partition them based on the date field. So you can see like the Coinbase is not giving us date value; they are giving date timestamp value. So date and timestamp are appended into a single column. It's called as trade time. So if we are going to partition based on the trade time, it will create multiple partitions because like it is at the second level. So what we are going to do, we have to take that date time, truncate the time part, and take the date alone, and partition them based on the date. And then I will showcase the benchmarking of saving the same data into a delta versus a traditional Parquet file. And I'm going to show you what is the time taken for each of them. So let me go here. So let me run this storage connection config. So this will connect to our storage bucket. I am going to delete any previously created um, folders for the same demo. So, so this is like a fresh run here. Okay, so let me explain through the code what I have done. It is the same old code, just that the folder is BTC USD partitioned. You can go and see here, like I have run the partitioned like this remove command to remove this BTC USD partition. So this should not be here. So okay, the Parquet alone is left, I think. Underscore Parquet. Okay, so this think partition Parquet. Yeah, now it has returned true. So this one is also gone. Parquet is also gone. So in this code, you can see I have uh, renamed the folder with the BTC USD partitioned, and I have also introduced another folder for the Parquet where I will be storing in Parquet format instead of the Delta format. And here is the benchmark function. So in this benchmark function is called, it will take the start time and end time, and it will give the difference, like how much time, like the duration of that action. So how much time a specific run has been happened. Suppose I am trying to do a count, or trying to do any kind of a sum or count aggregation activity, how much time it is taking, it will tell us. Okay, rest of the code are similar. In the input schema, I have, you can see there is a trade time, that is timestamp field. Okay, but while transforming into data frame, I have added trade date. That is, I am truncating the column, their trade time, and storing in a new column called as trade date. And I would be um, using while writing into the Azure data lake, I would be partitioning by trade date. Okay, so this is to improve the performance and optimization. And you can see I have also added another um, config to use the shuffle partition as 8 instead of the default is 200. This is also a performance optimization. If there is a huge data, we could increase the shuffle partitions. But if there is a very less data, this is very only 1,000 records per fetch, so we can reduce the partitions, because it will shuffle within the four cores only only 8 times. And this is the code to write into the lake house path with the partition on trade date. And I'm using another path for writing into parquet format without the delta mode. So this is with the delta mode, this is without the delta mode. Now I am calling the same benchmark function, and I am trying to read the delta as well as read the parquet. So I'm just reading it and getting the count. Both the functions are just reading the data and getting the count. So this benchmark will tell how much time it is taking for the delta for reading, and how much time it takes for the parquet to read for few thousand records. And similarly, how much time it takes for to filter for a specific partition date in delta, and how much time it takes to filter the data for a specific partition date, that is today's date, 21 September, uh, and tell the time for each of the partition date. And I'm going to print this value, like I have stored it in uh, an array list, and I'm just converting this into a data frame, and I'm showing that here. So let us run this code. Okay, so we can see here that while reading 1,000 records, the delta is taking 1 second, whereas Parquet is taking only zero point 0.6 seconds. So for less number of records, Parquet is faster. Like the storing into say, Parquet is faster, and reading from the Parquet is faster because it's very less record, and there is no parallelism happening. If you go and see here, I will refresh the. So you can see here, this is the partition one. This is the Parquet file format. You can see it is same because of four cores. It is divided into four, but the read is faster in the Parquet format for less for 1,000 records. Okay, if we are filtering for a specific date and then fetching the data from delta, it is only zero point 0.4 seconds, whereas in the Parquet it is taking zero point 0.9 seconds. So we can see the difference, right? The same data, like I have just run it fresh today, 21 September. So 21 September, I'm just going and fetching just by getting dot count. The delta is taking more time. But if I am filtering it and then taking the count, then the delta is able to perform better. So uh, the 1 second is reduced to zero point 0.4 seconds. And this is the fastest. You can see the delta with the filter is the fastest to. So in other words, when we are going to fetch from any delta format data lake house file or data frame, we have to apply partition date filter to fetch it in a very fast manner. And in Parquet, when we are applying the filter, it is actually increasing the count. So instead of zero point 0.6, it's taking 0.95 seconds. Let me run it once again so that the data is appended, and we will get more count, and we can see the benchmark information for the updated records. Yeah, see the count is increased. I think in the Parquet it is overwritten, right? That's why we are getting only 207 records. Yeah, the format is override. That's why we are getting only 207 records. But even with 207 records, it is taking 0.83 just to read with the filter. But the delta is 0.59. So can also make it as append mode and try, like, run for first run by removing the directories and running twice. So this is the first run. So this is similar to what we saw earlier, the first run, and this is the second run. Yeah, so 16 more records are added. uh, in any case, the filtered delta, the data from the delta format with filter on the partition date is the fastest. So even in Parquet, when we are applying filter, it is getting that the duration is getting reduced, but it's not as good as the delta. Let me run one more time to append more values and see whether we are getting more differences in the seconds. So this is the third iteration, and here we can see that the whole record itself is taking 0.72. So and the Parquet filter is actually 0.68. So as the data grows, the the delta will be performing better, but for less number of data, we can really make this benchmark of the time execution. But as the data grows, we can say, like, with the huge data, the delta would be performing much faster. Thank you.